Hello everyone. The title of this video is Graphing Ellipses Not Centered at the Origin. Okay, so in this video I'm going to be going over some examples that are taken directly from a free online textbook at openstacks.org. I'm in their Algebra and Trigonometry text, section 12.1, called the Ellipse, and I'm under the heading Graphing Ellipses Not Centered at the Origin. Each example I'm going to do is either an example from the reading or one of the try it problems from the reading or one of the exercises at the end of the section related to this particular objective. All right. So my assumption for this video is that you have either watched my videos previously on this section 12.1 where I graphed ellipses centered at the origin and wrote equations for ellipses centered at the origin and not centered at the origin. So I'm assuming all that. So if you haven't, watched the videos or looked back at previous material from this section, please do. Alright, so in this video, we're going to be given an equation of an ellipse that's not centered at the origin. It's going to be centered at some point with coordinates hk. Alright. And the only difference between these equations and the equations for an ellipse centered at the origin is that instead of x squared and y squared, it's now, the quantity x minus h squared and the quantity y minus k squared. Alright, so if you recall, again, all that previous stuff, this should be similar, right? Alright, and then you'll have so we have to know what h is, what k is, to identify the center of the ellipse. And remember these letters, there are letters A, B, and C. A was the distance from the center to a vertex, right, one of the ends of the major axis. B was the distance from the center to a minor, or a co-vertex, one of the ends of the minor axis. And C, see the C down here, step 2. C was the distance from the center to a focus, right? There were these two foci in an ellipse. And the relationship we use to find C, and this holds for any ellipse, is that C squared is going to be equal to A squared minus B squared. Alright. So I'm just going to get right into it. Like I said, we're given equations of ellipses that are not centered at the origin. We're asked to graph the ellipse and identify the center, the vertices, the co-vertices, and the foci. Alright. So first equation I'm given, we have the quantity x plus 2 squared divided by 4 plus the quantity y minus 5 squared divided by 9 equals 1. Alright, so this is in the standard form where the larger denominator is under the y squared term. So that larger denominator, that'll be the a squared. Remember, a is bigger than b for these ellipses. Standard form. And it's in this standard form, some quantity with x squared divided by b squared plus some quantity with y minus k squared divided by a squared equals 1. Right. So if we're going to graph this thing, and if you have graph paper, that'd be wonderful, use that. I'm going to make a rough sketch by hand, and then I'll show you the graph of it at that free online graphing calculator website called desmos.com. So first we identify the center. Right? Now if you'd like to, you can write this in exactly the same look as the standard form here, where, you know, x plus 2 is the same thing as x minus negative 2 squared, right? So the negative 2 is the value of h. Right, the value of h is what's being subtracted from x, not added. Another way to think of this would also be just think of the value you could replace x with to give you 0 up here. Right, if x were negative 2, you'd have 0 squared. So the x coordinate of the center is going to be negative 2. Then divided by, and then 4 is just, you know, 2 squared. Plus, and then y minus 5, that quantity. So 5 is the value of k. Right, k is 5, y minus 5 squared. Divided by, and then 9 is 3 squared equals 1. Right, so if you want, you can put it in exactly the same look as the standard form from the text. But yeah, so either way you look at it, we can pretty easily identify the center. Right, the center of the ellipse, the point h comma k, is in this particular case negative 2 for the x coordinate, positive 5 for the y coordinate. Negative 2 for the x coordinate, positive 5 for the y coordinate. And I'll go to a separate piece of paper and start plotting this stuff. Alright, so there's the xy axis. Right. So negative 2 for the x coordinate, positive 5 for the y coordinate, and then I'll put a little dot there. There's the center. Now you may recall too that the center isn't actually on the ellipse, right? The center doesn't satisfy the equation. If you replace x with negative 2 and y with 5, you'd get 0 plus 0 equals 1, which is false. So the center is not a solution, it's just a guide, right? Like a guiding point. Alright, then the value of a squared is the larger of the two denominators in standard form here. That's 9. So the value of a is 3, right? That's 3 squared. Now, I've mentioned this too, right? The larger denominator is under the y term. That means the major axis, right? The major axis is going to be parallel to the y-axis. In other words, is vertical. So the vertices, right, the ends of the major axis, you just take the center and we're going to add 3 and subtract 3 to the y coordinate, right? The major axis is vertical. So negative 2 and then 5 plus 3 would be 8. And then negative 2 and then 5 minus 3 is 2. So there are the vertices. And again, back on my picture, from the center, you know, negative 2, 5, I'm going to go up 3 units, down 3 units, and these points are actually on the ellipse. These actually satisfy the equation. There's negative 2, 8. Here's negative 2, 2. And that's the, you know, the major axis here. If I do a little dot, 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 right? There's the major axis. And again, you can check it out. Plug in negative 2 for x, and plug in 8 for y or 2 for y, and this will be a true statement. You will have a solution. Alright, then to find those co-vertices, right, the ends of the minor axis, I need the value of b. Now b squared is the, you know, smaller of the two denominators in standard form. B squared is 4. So that means b is 2. Right, we saw 2 squared. And then I can use this to find the co-vertices. And a good way to think about it is, you know, this is under the x, so I'm just going to add and subtract 2 to the x coordinate of the center. So negative 2 plus 2 would be 0. So 0, 5 would be a co-vertex. And negative 2 minus 2 is negative 4. Right? So negative 4, 5 is another co-vertex. These are actually solutions. Right, and on the graph, I go from the center, go right 2 units. Here's 0, 5. And then I go left 2 units to negative 4, 5. And there are the two co-vertices. Right, here's the minor axis straight across there. Should be perpendicular to the major axis. Then once you have the vertices and co-vertices drawn, you should be able to draw a rough sketch of the ellipse, right? Just don't make it a diamond, right? Don't draw straight segments, make it curvy, make it like an oval. All right, and then finally, now that I have the graph down, we should be able to also find where the foci, right, the two focuses, foci of the ellipse are, and that involved finding that value of c, right? And the relationship between c, a, and b for all ellipses is c squared is a squared minus b squared. We know a squared is 9, b squared is 4, so that's 5, and then c must be the square root of 5 then. And once again, the major axis is vertical, right? The foci are on the major axis always. So remember how for the vertices I added 3 and subtracted 3 to the y-coordinate of the center? I'm going to do the same thing with this c to the y-coordinate of the center. Right? So the foci are at negative 2, right? The x-coordinate of the center doesn't change. And then I'm going to take the y-coordinate of the center and add and subtract the square root of 5. And there's the foci. Now the square root of 5 is a little more than 2 units. So if I go up square root of 5, I'll be between 7 and 8 here. Here's 5 plus the square root of 5. There's a focus. And then if I go 5 minus the square root of 5, I'm down between 2 and 3 units. That's between 2 and 3 here. On the y-axis, there's 5 minus the square root of 5. And another focus, right? The two foci should be on the major axis. And they're not solutions, right? Just like the center, the foci are not solutions. If you plug in negative 2 for x and then 5 plus the square root of 5 for y, or 5 minus the square root of 5 for y, they don't satisfy the equation. Right? What's important about the foci was the following. And again, I'm assuming you remember a lot of this stuff from previous videos, previously reading this section. But remember how the foci are used in the definition of an ellipse. If you were to take any point on the ellipse, take any point at all, calculate the distance to the first focus and the distance to the other focus, call that maybe D1 and D2. D1 plus D2 is always going to be equal to the length of the major axis, which is 6 in this case, 2 times A. And that would work out for this particular ellipse for any point. You take any point on this ellipse, calculate the distance to negative 2, 5 plus root 5, and then calculate the distance to negative 2, 5 minus root 5. Add those distances, it will always be 6. Always. Right, for this ellipse. Right, it always ends up being whatever the length of the major axis is for any ellipse. Right, but I'm only going to mention this once though. And we'll find the foci for other ellipses, but not worry so much about that definition. Okay. And now just to make sure everything's looking good here, I'm going to go to that Desmos site, free online graphing calculator at desmos.com, and just enter the equation we were given and see what the graph looks like. So it was the quantity x plus 2 squared divided by 4 plus the quantity y minus 5 squared divided by 9 equals 1. And there's our ellipse. And hopefully you can clearly see that the point negative 2, 5 is the center. I'll plot the point negative 2, 5. Right, you see that blue point just pop up there. There we go. definitely in the center. And then you see, remember A was 3, and I went up and down. If I go up 3, all right, there's the vertex, one of the vertices at negative 2, 8. That was one of the vertices I wrote down. Then down 3 from center, negative 2, 2. And then I went right 2, B was 2. The value of B was 2. I went right 2 for co-vertex 0, 5. And then from the center, left 2 for co-vertex negative 4, 5. Exactly what I have on my drawing. Alright, and then if you'd like to see where the foci are, remember those were at negative 2, comma 5 plus the square root of 5. And there's that point that just showed up there on the major axis, this point here. There's one focus. And then the other focus, I'll just copy and paste this and change the plus to a minus. There's the other focus. And again, you take any point on the red ellipse, take any point on the ellipse, take the distance to the purple point plus the distance to the green point. These two foci, add them up. It'll always be the length of the major axis. It'll always be 6 for this example. All right, so it looks good. Looks like we did all right. All right, so next example, same thing. I am given an equation that's already in standard form. It's some quantity with x squared divided by a number plus some quantity with y squared divided by a number equals 1. Right, so this is already in standard form. We're going to see equations coming up that are not in standard form. So we have to do something to put it in standard form, but we'll get to that in a second in example 3. Alright, so this one, see the larger denominator is under the x term, 36 and 20. So this one's going to have a major axis that's horizontal. The major axis is horizontal, or you would say the major axis will be parallel to the x-axis. Alright, now the center is easy enough. Alright, that value of h and k. Just again, I like to think of just what would make me have 0 squared here and 0 squared here. Right? X minus 4. If x were 4, you'd have 0 there, so 4 is the x coordinate of the center. And if y were positive 2, you'd have 0 there, so 4, 2 is the center. And I'll start plotting some of this stuff. Or 2. So there's the center. And then again, the larger denominator, that's a squared. Right? A squared is 36. So a is 6. And I can use that to find the vertices. Right? The vertices are 6 units away from the center, and they're right and left. Right? The vertices should be on a horizontal line. So I'm going to add this 6 to the x coordinate and subtract it from the x coordinate of the center. All right, so 4 plus 6 is 10, and then the y coordinate's not changing, so 10 comma 2. And then 4 minus 6 is negative 2, and then again the y coordinate doesn't change. So right 6, there's 10, 2 for one of the vertices, one of the ends of the major axis. And then left 6, 4, and then 5, 6 is negative 2, 2 for the other end of the major axis. Those points are actually on the graph of the ellipse. They actually satisfy the equation. And you can check that out yourself. Alright, then the smaller denominator, right, b squared, is 20. So b is the square root of 20. Which reduces or simplifies to 2 times the square root of 5, right? That's the square root of 4 times the square root of 5. Now that's between 4 and 5 units. So from the center, going square root of 20 units up and square root of 20 units down. All right, so using these, we can get the co-vertices. And I'm just going to be adding and subtracting this b to the y coordinate of the center. So 4 and then 2 plus or minus 2 root 5. Those are the co-vertices. Now again, the square root of 20 is between 4 and 5 units. 1, 2, 3, 4, 5. So between 6 and 7, that's going to be 2 plus 2 root 5. And there we go. 4 comma 2 plus 2 root 5 for one covertex, and then again between 4 and 5 units below. So 1, 2, 3, 4, 5. So between -2 and -3 is 2 minus 2 root 5. And there's the other covertex. There's 4 comma 2 minus 2 root 5. And now that I have the vertices and covertices in, I can make a rough sketch of the graph. Alright, and then again, if you want to label the major axis, like here's the major axis, and here's the minor axis perpendicular to it. If you want to put those in, you can. There's nothing wrong with that. They're just not actually part of the ellipse. And then the foci, I need that c. Right? So c squared is a squared minus b squared, which would be 36 minus 20, which is 16. So c equals 4. And then using c equals 4, we can find the foci. And then just like with the vertices, I do the exact same thing I did to the vertices to find the foci. The foci and the vertices should be on the same axis. For the vertices, I added and subtracted 6 to the x-coordinate, right? The major axis was horizontal. So here I'm adding and subtracting 4 to the x-coordinate of the center. So if I add 4, that's 8, 2. And if I subtract 4, that's 0, 2. Alright. So here's a focus, 0, 2, and then another focus is at 8, 2. And I'll put like F1, F2 for focus 1 and focus 2, but there's the foci. And again, the reason they're there is because if you took any point on the ellipse, took the distance to one focus and added the distance to the other focus, it would always be 12. Right, 2 times a would always be the length of the major axis, but again, I'm not worried about that right now. Alright, and I'll leave it to you to put that in the Desmos calculator and check, see how it looks compared to this, and make sure the vertices and co-vertices are in the same places, and the center, of course. Alright, so the first two examples, the equation was given to us in standard form. In the next examples, two examples I got, and then more later, we're going to be given an equation that's not in standard form, but have to put it in standard form. We'll see how to do that. So this is actually an equation of an ellipse, even though it might not look like it at first. But clearly, this is not in that standard form. Where we have some quantity with x squared over some number plus, and then some quantity with y squared over some number equals 1. And again, we could have a squared here, b squared here, or the other way around. Okay. So I'm trying to get some quantity with x squared over a squared or b squared plus some quantity with y squared over some number equals 1. Right? And that's the goal. And here's how we're going to do it. All right. We're going to complete the square on the x's and y's, on the x terms and y terms. Now I'm going to assume that you remember how to complete the square. All right, I'm not doing a whole lesson on that. So if you don't, look up completing the square or some other video of mine or something earlier from some other lesson somewhere, wherever. I'm not going to be teaching how to do that here. I mean, I'm just going to do it. So first I want to group the terms with x together and the terms with y together on the same side. So here we have 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. I'm going to put the x squared terms next to each other first. So 4x squared, minus 40x. And then the y squared terms next, plus 9y squared. I'm just rearranging the terms. Plus 36y. And the only term I don't really need when completing the square is the constant term. So this plus 100, I'm going to subtract that. So we have 0 minus 100, negative 100 on the other side. All right. Now, remember to complete the square. The lead coefficient, the coefficient of the squared term, needs to be 1, not 4, and not 9. And we're going to do these x's and y's separately. Right? So from the x terms, it's very easy to fix that. If I want to turn this 4 into a 1, I just need to factor out a 4. So I factor out a 4 from the x terms. And then the same thing goes for the y terms. If I want to complete this square on these y terms, the coefficient on the y squared term needs to be 1, not 9. So to fix that, make it into a 1, I'm just going to factor out that 9. So now, from the x terms, if I factor a 4 out, we have 4 times the quantity, x squared minus 10x. And now because there's a coefficient of 1 on x squared inside the parentheses here, I'm going to leave some space for that number we're going to add to complete the square. Then plus, and then from the y terms, I factored out 9. Alright, and factoring out a 9 leaves me with y squared plus 4y. And then again, because there's a 1 y squared, and inside the parentheses here, I'm going to leave some space and leave some space, then close the parentheses, and we're going to add a number in here. We're going to complete the square inside that set of parentheses. All right, equals negative 100. All right, now comes the completing the square part. So we're going to do that in this line. So inside this first set of parentheses, we've got x squared minus 10x. Remember, you take half the linear coefficient and square it. That'd be negative 5, and then squared is positive 25. Now here's the problem most people make here. Remember, you got to keep the equation balanced. Most people will add 25 here and then, oh, I got to add 25 over here, but that wouldn't be balanced. You have to remember what you factored out before. If I add 25 inside this set of parentheses, and you put this 4 back in, that would be 4x squared minus 40x, and then plus 100. 4 times 25 is 100. So if you add 25 in here, what you're really adding to this left side is 100. So that's what I need to add to the other side to keep it balanced. And again, this comes from 25 times the 4 that we factored out. Same thing here. When I'm completing the square on the y's, y squared plus 4y, to complete the square I would have to add 4 inside this set of parentheses. But don't add 4 to the other side, that wouldn't be balanced. If I add 4 in here, remember I factored out a 9 earlier, 9 times 4 is 36. So adding 4 in here is actually adding 36 to the left side, so I must also add 36 to the right side. And again, where that comes from is the 4 that I added times the 9 that was factored out. You got to remember what was being factored out here. All right, now if you recall completing the square, right, the whole reason we add these numbers is to get perfect square trinomials, things that can be rewritten as squares. So this first product is the same thing as 4 times, and then x squared minus 10x plus 25, pardon me, is the quantity x minus 5 to the second power. Plus, and then we have 9 times, and then this y squared plus 4y plus 4 is the quantity y plus 2 squared. And then adding the stuff up on the right side gives me 36. All right, so I'm almost there. I'm almost in standard form. But notice, so see I got my quantity with x squared plus, some quantity with y squared. Yeah, there are times a number, but those will be gotten rid of in a second. It's the other side I'm worried about. In the standard form, it's equals 1. Here it's equals 36. Again, very easy to fix that. Just divide both sides by 36. Because anything divided by itself is 1, and that'll give me the equals 1 on the right side. All right. And then the nice thing is that these coefficients of the squares, 4 and 9 here, go into 36 evenly. So when you take this first product divided by 36, 4 goes into 36 9 times. This becomes the quantity x minus 5 squared in the numerator divided by 9 in the denominator. Plus, and then the second product, when divided by 36, 9 goes into 36 4 times. So you have the quantity y plus 2 squared in the numerator divided by 4 equals 1. And now, finally, this is in standard form. Some quantity with x squared divided by a number plus some quantity with y squared divided by a number equals 1. This is in the standard form for an ellipse, centered at the point 5, negative 2. All right, now I'm going to do basically what I did in the first two examples. Now that I've changed this to standard form, should be able to easily find the graph, find the center, the vertices, the co-vertices, the foci, should be able to easily do all that stuff now. So the center as 5 for the x coordinate, negative 2 for the y coordinate. The larger denominator is under the x, so the major axis is horizontal. The major axis is parallel to the x-axis. The value of a squared would be, again, the larger denominator, 9, meaning that a is 3. And so the vertices, I would add 3 and subtract 3 from the x-coordinate of the center. Go 3 to the right, 3 to the left for the vertices. So 5 plus 3 is 8, negative 2 is one vertex. 5 minus 3 is 2, negative 2 for the other vertex. B squared is the smaller denominator, 4. So B is 2. And I'm going to add and subtract this to the y-coordinate of the center for the co-vertices. Right, the minor axis would be vertical if the major axis is horizontal. So negative 2 plus 2 is 0, so you got 5, 0 for one of the co-vertices. Negative 2 minus 2 is negative 4, so 5, negative 4 for another co-vertex. And all of these ordered pairs are on the ellipse. These should all satisfy the equation I have. Even the first equation, way back in the beginning, right, this long one. All these ordered pairs should satisfy that equation as well. And you can check that out on your own. And then c squared is going to be 9 minus 4, that's 5. Right, so remember, it's a squared minus b squared. So c is the square root of 5. And then we can get the foci out of this, the two focuses. And do the same thing I did to the vertices. Right? Major axis is horizontal, so I'm going to add and subtract the square root of 5 to the x-coordinate of the center So 5 plus or minus the square root of 5, comma negative 2, there's where the two foci will be. And of course I'll draw this up, make a rough sketch of it, and then we'll go to the Desmos site. The center was at 5, negative 2. The vertices were 3 to the right and left of that. So 8, negative 2, and 2, negative 2. And then, 5, 0, 5, negative 4, 2 above and 2 below the center. And there's your graph. And the foci will be on the major axis somewhere. You can plot those yourself. But 5 plus the square root of 5, comma negative 2, 5 minus the square root of 5, comma negative 2. But something like that. All right. Now what I'm going to do is I'm going to punch in the original equation to Desmos and see that these are the vertices and co-vertices. Alright, so the original equation we were given was this, 4x squared plus 9y squared minus 40x plus 36y plus 100 equals 0. And look at that ellipse that just showed up. And see the 5, 0, 5, negative 4, those were the co-vertices. Here's 8, negative 2, and 2, negative 2, the vertices, right? The center is clearly at 5, negative 2 as well. So it looks like, I did a good job. It matches. Great, but yeah, that's the thing though, right? Given an equation like this, put the x terms together, y terms together, constants to the other side. You might have to factor out the lead coefficient, the square coefficients, complete the square, get it in standard form, and then you can do all the rest pretty easily, I feel. So I got another one like that. So here 4x squared plus y squared minus 24x plus 2y plus 21 equals 0, another equation of an ellipse. So I group the x terms together, 4x squared minus 24x, plus the y squared, group the y terms together, y squared plus 2y. And then, this positive 21 I don't really need over there, so I'm going to subtract 21. That gives me negative 21 on the right side. From the x terms, I'm going to factor out a 4 so that we have 1x squared. Right, so this is 4 times the quantity, x squared minus 6x. And then I'm going to leave some space and we'll complete the square inside those parentheses. Now I don't need to factor anything out of the y's. There's already a 1y squared. So I can leave that the way it is. Oh, sorry, I meant to put 2y there. Plus 2y. Y squared plus 2y. And then leave some space to complete the square there equals, negative 21. Now comes the completing the square part. On the x's, x squared minus 6x, I'd have to add 9. But don't forget, if you add 9 in the parentheses here, right, I factor out a 4. So really that's adding 36, 4 times 9, to the left side. So I must add 36 to the right side to keep it balanced. Now in the y terms, I don't have to worry about what I factored out because I didn't factor out anything. So y squared plus 2y, I would just add 1 to complete the square on the y's and then just add 1 to the other side. Okay, so here we have 4 times this quantity is x minus 3 squared plus, and then this quantity is y plus 1 squared. That's a perfect square trinomial. Equals, and then basically you have 37 minus 21 would be 16. Alright, again, I'm almost done. just want an equals 1 over here. So I divide everything by 16. And 4 goes into 16 4 times, so this first term becomes, x minus 3 squared over 4 plus, and then there's nothing to cancel in the second term, so you have y plus 1 squared over 16 equals 1. So there's the same equation in standard form. Now it's in the standard form for an ellipse. Alright, so the center would be at 3 for the, have a 3x coordinate and a negative 1y coordinate. And then we'll move from here to get to the vertices and co-vertices and the foci. Now a squared would be 16. Alright, it's the larger denominator. B squared would be 4. So a is 4. Alright, and it's under the y, so I'm going to add this to the y coordinate of the center. Add and subtract 4. So the vertices are 3, and negative 1 plus 4 would be 3. Negative 1 minus 4 would be negative 5. So 3, 3, and 3, negative 5. These are actually solutions of the equation. And you can check that out. Go to even go back to the original equation. Plug in 3 for x and 3 for y, and it should satisfy it. Or 3 for x and negative 5 for y. And then b is 2, right, the square root of 4, and that's under the x, so I'm going to add that to the x coordinate, add and subtract to the x coordinate of the center to get the co-vertices. So the co-vertices, 3 plus 2 is 5, so you got 5, negative 1, and 3 minus 2 is 1, so 1, negative 1, right? There are the co-vertices, and those are also solutions of the equation. You can plug those values in and see that they make the equation a true statement. Alright, and then for the foci, c squared would have to be 12, right? 16 minus 4. So c must be the square root of 12, or 2 root 3. Right, 2 root 3. And then the foci, remember for the vertices I added to the y coordinate, so I do the same thing for the foci. I add and subtract this value to the y coordinate of the center. So it'd be 3 and then negative 1 plus or minus 2 root 3. Here's where the foci would be. Alright, and I'm just going to go and plug this in instead of drawing it. I know they asked me to draw it, but I've done 3 examples already. I'm just going to plug this into the Desmos calculator and see that those vertices and co-vertices are what I wrote down. Because if the vertices and co-vertices are correct, my graph by hand would be the same as what it's supposed to be. Okay. So the equation we were given was 4x squared plus y squared minus 24x plus 2y plus 21 equals 0. There's an ellipse, and the center should be at 3, negative 1. And look, right, if I go 2 to the right, there's 5, negative 1, right? That was one of my co-vertices. I wrote that down. Go to the left 2, there's 1, negative 1. That was another co-vertex. I had that written as well. And then go up 4, right, there's 3, 3. That was a vertex I had. And then down 4, 3, negative 5. That was another vertex. So if I were making a graph by hand, I would have plotted those 2 vertices, the 2 co-vertices, and then drew a sketch like this. Okay, looks good. Alright, so now we're going back to a couple examples that are already in standard form. Alright, so again, I'm not going to draw them anymore. I'm just going to go to Desmos each time, and I just want to identify the center, the vertices, the co-vertices, and the foci, and then you can plot them yourself if you want. So this is already in standard form, right? You got a quantity with x squared divided by a number plus a quantity with y squared divided by a number equals 1. So the center, again, should be easy to identify when you're in standard form. 2 for the x coordinate and negative 1 for the y coordinate. and then the value of a squared is the larger denominator, so a squared is 81, b squared is 16. So a is the square root of 81, that's 9. And since that's under the x, I'm going to add and subtract 9 to the x coordinate of the center, and that'll give me the vertices, the ends of the major axis. 2 plus 9 is 11, right, so you got 11, negative 1 is a vertex, and 2 minus 9 is negative 7. So negative 7, negative 1 is another vertex. And then b would be 4, the square root of 16, and that's under the y, so I'm going to add and subtract 4 to the y coordinate of the center for the co-vertices. So same x coordinate, and I'm just adding 4, negative 1 plus 4 is 3, so 2, 3 is a co-vertex. And then again, same x coordinate 2, and then negative 1 minus 4 is negative 5, so 2, negative 5 would be another point on the ellipse, another co-vertex. And then c squared will be a squared minus b squared, 65. Right, 81 minus 16 would be 65. So c is the square root of 65. Right, something a little more than 8. So the foci are like a little more than 8 units away from the center. And remember, for the vertices, I added to the x-coordinate, so I'm doing the same thing with this for the foci. Take the center and just add and subtract this value to the x-coordinate. So 2 plus or minus the square root of 65, comma, and then the y-coordinate's the same, negative 1. These are the foci. And once again, I'll punch this in, and we'll see if the vertices and co-vertices are correct, because that's how I would have drawn it by hand also. So we have the quantity x minus 2 squared divided by 81 plus the quantity y plus 1 squared divided by 16 equals 1. Here we go. Right. Center, clearly, hopefully you can see it's at 2, negative 1. Right. That should be the center, and then look, if I go 4 units up, there's 2, 3. That was a co-vertex I wrote down. 4 units down, 2, negative 5. That was another co-vertex I had written. 9 units to the right, there's 11, negative 1. That was a vertex I had. 9 units to the left, there's negative 7, negative 1. That's another vertex I wrote. So I would have plotted those same points and drawn this same picture. It wouldn't have been as nice looking, but it would have been still a rough sketch of it. All right. So I got another one. All right. So this one here, if you notice, see how the denominators are the same? This is in standard form. You get a quantity with x squared divided by a number plus a quantity with y squared divided by a number equals 1. But you notice how these denominators are the same number. That means that this is going to be a circle. All right, and again, I've done a lesson in the past about circles. All right. You could also go to section 11.1. 11.1 of the OpenStax intermediate algebra text. We'll look more about circle lessons. But we're going to see that this is a circle, right? There is no major axis or minor axis. It's going to be the same distance all the way around. We'll see that here, right? So the center is 7 for x, 7 for y. And then, it doesn't really matter. I mean, since they're the same value, I mean, they're a squared and b squared, or b squared and a squared, it doesn't matter, right? Because either way, a and b are the same value. They're both 7, right? Square root of 49. So for the vertices and co-vertices, I'll just call them all the vertices here, because again, it's going to be the same distance on either side. One is, I add and subtract 7 to the x-coordinate, so 14, 7, 0, 7, right? Those will be on the graph. And then the other two, I'll add and subtract 7 to the y-coordinate. So 7, 14, and 7, 0. So here's the vertices and co-vertices. Again, really they can be used interchangeably since we're doing the same distance on both. And then the foci is just going to be the center. Foci equals focus equals center. All right, because what will c squared be? C squared is going to be 0, meaning c is 0. So the foci, the focus, is just one focus, just the center of the circle. All right, a circle has just one focus, and that is the center. All right. So this is a pretty, simple, an example of an ellipse, a special ellipse, right? Circles are just a very special kind of ellipse where both foci just end up being the same point at the center. All right. And again, we can see this here. I'll graph it. Quantity x minus 7 squared divided by 49 plus quantity y minus 7 squared divided by 49 equals 1. And yeah, this is very, very circular. All right, there is no major or minor axis. It's the same distance all the way around, right? The center is at 7, 7. And no matter what direction you go in, 7 units right, 7 units down, 7 units left, 7 units up, you're on the circle. All right, there's 14, 7, 0, 7, 7, 14, 7, 0. All right, the same 4 points that I wrote. Okay. So yeah, so I would have plotted those points and made this kind of a drawing. All right, wonderful. All right, next example. I've just got 3 more. So there's another one where the equation's not in standard form. Got to put it in standard form. So now that I've shown you a few of these already, I'm just going to kind of rush through it. Just bear with me here. Now it's already set up where the x and y terms are together. So from the x terms, I'd factor out 9. So we have 9 times then x squared minus 6x. And then I'm going to leave some space to complete the square. All right, then on the y terms, I'm doing the same thing. I'm going to factor out 9. And we're going to see that this will actually be a circle as well. Just like example 6. And then we have again y squared minus 6y. Leave some space. And then the 81 I'm going to subtract. We'll have negative 81 on the other side. And you might want to do this now. You might notice, hey, 9, 9, 81, those are all multiples of 9. So if I divide by 9 on both sides, this just becomes the quantity x squared minus 6x plus, and then the 9 cancels here too, y squared minus 6y equals, and then dividing this by 9 makes it negative 9. And now comes the completing the square part, and I don't have to worry about what I factored out anymore since I divided through by 9. Here I would add 9 to the other side, same thing here. I would add 9 to the other side. And so we have the quantity x minus 3 squared plus the quantity y minus 3 squared equals 9. And this is a circle. Right, it's a circle with a center at 3, 3. Right, 3 for x, 3 for y. And in both cases, if you divide through by 9 and get it to be like x minus 3 squared over 9 plus y minus 3 squared over 9 equals 1, you'll see that there's no major axis, no minor axis. Right? You're going the same distance in all directions. And remember, you might recall this is the radius of the circle squared. So the radius of the circle would be 3 units. So the vertices and co-vertices would all be, 3 units away from the center. So just a couple of them will be if I add 3 and subtract 3 from the x coordinate. So 6, 3, and 0, 3 are on this, and add 3 and subtract 3 from the y coordinate. So 3, 6, and 3, 0 are also on this, vertices and co-vertices. And the foci would be the center again, because c squared would be 0, right? C would be 0. Because both a squared and b squared are 9 if you divide it through by 9. Right, so let me show you. Let me show you with the graph. You'll see a circle show up here again. So 9x squared minus 54x plus 9y squared minus 54y plus 81 equals 0, 0, and there's a circle. 3, 3 is the center, so you got 3, 0, 3, 3, 0, 3, 6, 3, and 3, 6, right? All those vertice points that I wrote are on there, and I would have plotted those and graphed this circle. Right? And of course the center 3, 3 is there as well. But it's not a solution. Remember, the center is not a solution. It's just a guide. Okay, 2 more. So one in standard form and one not in standard form again, and then we'll be done. Right, so again, very easy if it's in standard form like this. The center would be 0 for x, negative 1 for y. Then a squared is 5, b squared is 2. So a is the square root of 5. All right, and then the vertices, I'd be, since that's under the y, I'd be adding and subtracting this to the y coordinate of the center. So 0, comma, negative 1 plus or minus the square root of 5. There's where the vertices would be. And then b would be the square root of 2. And that was under the x, right? So for the co-vertices, I'd add and subtract the square root of 2 to the x value of the center, which will just be plus or minus square root of 2, comma, negative 1. And then c squared would be a squared minus b squared. 5 minus 2 is 3. So c is the square root of 3. And then I do the same thing as I did with the vertices. I'm going to add and subtract this to the y coordinate of the center. So the foci would be at 0 and then negative 1 plus or minus the square root of 3. Right? There's all the stuff they want. And again, I'll go to make a graph of this, and we'll see that all these are actually the points on the graph. Right? So the equation was x squared divided by 2 plus the quantity y plus 1 squared divided by 5 equals 1. Right? There's an ellipse. Centers at 0, negative 1. Right? Hopefully that's clear. I'm just going to plot one of the vertices. Right? We had 0, comma, and then negative 1 plus the square root of 5. And you see that black point that just showed up? So that's the square root of 5 units above the center. And then negative 1 minus the square root of 5 would put me the point down here. And then I'll just plot one of the co-vertices. Was at positive square root of 2, comma, negative 1. And you see that red point? It's definitely on the ellipse. And if I do negative square root of 2, comma, negative 1 will be on the other side. And then you can plot the foci inside the ellipse as well on the major axis. But again, the foci are not actually solutions. So, looks good. Alright, and then I just got one final example. Alright, it's one of those again where the equation does not start off in standard form. I have to put it in standard form. Now the x terms, they already have 1x squared. So I'm just going to leave space right now to complete the square. On the y terms, I'd factor out a 25. And then you'd have 25 times the quantity y squared minus 4y. And then I'll leave some space inside the parentheses here to complete the square on the y's. Equals negative 91, right? I don't need the 91 here. I'm just going to subtract 91 from both sides. Alright, now the completion of the squares. On the x's, I would add 16 do the same thing to the other side, because there was nothing factored out of the x's, so I don't have to worry about that. On the y's, I would add 4. And if I add 4 in here, remember I multiplied by 25, I factor out 25. So adding 4 inside this set of parentheses is really adding 100 to the left side, so I have to add 100 to the right side. Okay, so now this x squared minus 8x plus 16, that's the quantity x minus 4 squared, plus 25 times, and then this y squared minus 4y plus 4 is the quantity y minus 2 squared. And then over here we have 25. Adding up all those numbers. Yeah, and then I just divide everything by 25. So we have x minus 4 squared divided by 25 plus, and then 25 goes into 25 once, right? So this is just going to be y minus 2 squared over 1. You can put over 1 if you want, but usually people don't do that. Equals 1. So here's the equation in standard form. No, it's not the final answer, but now that I have it in standard form, should be able to identify all the important points. The center of this ellipse is 4 for x, 2 for y, right, the point 42. A squared is 25, b squared is 1. Right, remember the denominator of that is 1, and the larger of the two is a squared. So a is 5, and from that I get the vertices. Now that's under the x term, so I'm going to add and subtract 5 to the x coordinate of the center. 4 plus 5 is 9, so 9, 2, and 4 minus 5 is negative 1, right? So 9, 2, and negative 1, 2 are points on the ellipse. They're on the ends of the major axis, the vertices. The value of b would be 1, and it's under the y. I'm going to add and subtract 1 to the y coordinate of the center, so we have 4, 3, and 4, 1 are the co-vertices. And then c squared would be a squared minus b squared is 24. So c is, the square root of 24, which is 2 times the square root of 6. And I do the same thing I did with the vertices. I'm going to add and subtract this value to the x coordinate of the center, right, to get the foci. So 4 plus or minus 2 times the square root of 6, comma 2. That's where the foci will be. All right, and then there's one final check here. I'm going to put this equation into Desmos and see if all these vertices and co-vertices match up. See if those are correct. So that final equation I was given is x squared minus 8x plus 25y squared minus 100y plus 91 equals 0. And the center should be at 4, 2. And look at that. And you see 1 unit above, there's 4, 3. That was one of the co-vertices I wrote. 4, 1. And then 5 units right, got 9, 2. 5 units left of center, there's negative 1, 2. Right? The same vertices that I wrote. So I would have drawn all that and drawn a rough sketch of this ellipse myself. Great. All right. So yeah, I'm hoping that watching me go through these 9 examples here help you in some way when you're asked to graph an ellipse that's not centered at the origin on your own and identify all those key points. And thank you very much for watching.